Well, Parth, I'm just thinking since none of us almost really have anything much to offer in the call other than a group discussing this, since you could, if you wanted to, you could show us, do screen share. It'll be a research thing. You could show us what you found, where you've gotten to, what the resources were you looked at, whatever, and then what you need to know next, and maybe we could, if you want to do that.
Yeah, so I can, so I was just planning to go through the notebook. I haven't gone through yet, but I have it open. So I can share that. Okay, give me a second.
Yeah. While we're waiting, I have a question. So I have not seen a pseudo rehearsal before. Do you know if this is still like a mainstream way of fighting catastrophic forgetting? Okay.
No. This guy, so I forget his name, but the guy who's responsible for building the, so Spacey has a very specialized model, okay, where it sort of combines old school. It's a deep neural network, but he has a video where he describes how it combines old school sequence. I don't know if it's called sequence classification, but all of named entity recognition used to be all sequence-based stuff. He combines that with with the modern neural network approaches and now with transformers, and so this special model they use in general for their Spacey stuff. So he commented on, he found that when he tried to train a custom entity, right, he ran into this pseudo forgetting, and he researched the literature. So he did find an old paper that maybe called it something different, and he links to it. So it has some basis, right, in research, but it's not widely used or well known. So if you want to understand it, try to help you in other circumstances, I don't know. Maybe. Was that kind of what you were wondering?
Yeah. Thanks.
Yeah, it's like he dredged something up. It's like, wow, I didn't come up with this; it already existed.
By the way, what's the normal technique against catastrophic forgetting is to still kind of mix the original training data, right?
I guess so. I can't remember. He discussed it. I really don't know anything about it.
Right.
When I read more about it, so one of the Spacey person mentioned that they are in their next update. They have more improvements to do on the pseudo rehearsal thing. So maybe this
good.
3 might have a major improvement.
Good. So I decided not to struggle. I'd rather learn about QA.
Yeah, that's what I'm also curious, because QA is kind of a new thing.
I'm assuming either he'll adjust the model so it doesn't have a pseudo forgetting problem, or he'll probably make it easy to do the pseudo rehearsal, so it doesn't do catastrophic forgetting.
Yeah. So do you guys want to go through this notebook together? Or okay. Yeah, so I was just going through this starter pack, since it seems like it's the one to start with transformers. So they're treating the sentiment column as a question. So whether it's a positive or negative, the context would be the actual training text column, and the response or the answer would be the selected text, the variable y.
So your question isn't really, is this positive? The question is, why is this positive, sort of, right?
Yeah.
I guess.
So it's kind of I guess that's the way they want it to format, because right, it's like this here. That's the training data format, the way they want. So here the context would be the tweet, the actual tweet.
Right. I understand what you're saying. They're saying that because it's a data structure. I'm with you. That's how the model works.
Yeah.
Oh, sweet.
And then a few resources. I found this one very good. The Stanford CS2 to 4N. And then this is a good repository for all the question answering recent trends. There are a lot of things.
What is that?
So it's a GitHub repository, awesome question answering, and it has basically all the resources that we need uh, for like recent trends. Then all the language models for question answering, like TinyBird,
Yeah, I
Transform.
get it. I know it's an awesome list. I've heard of those.
Yeah. Uh, and and there's this blog which I briefly went through, but it's a very good one. Build a question answering system from scratch. Um, so they are seems from reading through it, it seems like they're using Distilbert. Uh, I briefly, I do not know if anyone knows more about this, but I briefly know that it's just a faster version of Bird. Does anyone know more about Distilbert?
Yeah, they use the teacher training. They used. Remember, I think we talked about it on Thursday, right, Yuri? They use a teacher training, whatever that means, architecture to reduce BERT to a smaller size, so it's as effective with less parameters. But whatever a teacher-student model is, I kind of have a half idea of that.
Oh, yeah. So, uh, it, so they mentioned that most of the more hidden features that BERT uses, they could be uh, like where was that?
Excuse me.
It is possible to reduce the BERT model by 40% while retaining 97% of its language understanding capability. So it makes it 60% faster.
Yep. It's just a more manageable BERT. I mean,
Yeah.
in the competition, people seem to be using Roberta for the QA. I don't know why. I don't remember what Roberta is particularly, but I think it's trained
Yeah.
on maybe a different task or something. I don't know.
So yeah, based on the Thursday call, I think someone mentioned that Roberta is much powerful. It is trained on much more data, if I remember it right. So
The
maybe
new
it gives
Roberta.
better
Okay.
performance.
Yeah.
So again, what this person is using is the simple transformers API, which is kind of an API built on top of transformers. So it just makes it easy to use the transformers library. It's right here. Simple transformers. Yeah, it's I think something built on top of transformers. So it just makes it very easy to train and evaluate all the transformer models. Again, so as this is not in the Kaggle image, we have to first open a separate notebook, uh, download the simple transformer, their Wheeler files, and then use that as a data set to use the library. It didn't work for me for Flare, but for simple transformer, it works. This is basic. Yeah, so I think just copy and pasting this would work to format the data set in the QA compatible format. Similarly for the test. And yeah, so those are the Wheeler files which we need to get the simple transformers library. And we need that because the internet is off. So we want it to download from local environment.
Say that again. What's going on there?
So remember, I wasn't able to use Flare because we have to pip install them through
Yeah.
internet. But if you use it as a data set by downloading all the Wheeler files, the WHL files, and then load them in your input, if we can see
Oh
the
yeah. This is the workaround. I saw this.
yeah.
I didn't do it. That's cool. So this is the workaround and you feel like you could, but that didn't work for Flare. That workaround.
Yeah, because Flare had for this there are only two Wheeler files. Flare had like 25, 26, and for some it was causing dependency issues, so it wasn't
I see.
working. Yeah.
Yeah.
But yeah,
I thought you were working mainly in Colab, but I guess because this notebook's here and you're playing with it, you're doing it in Kaggle.
right, yeah.
Yeah.
And yeah, so the simple transformer seems like very easy to use. So just simply import question answering model. Then for model path, we have to, again, since internet is off, we have to again load it. So there are a bunch of models already uploaded by people on Kaggle already. So we can simply go to upload data and just do a search, and we can find this one, distilled bird, uncased distilled squad. And then just simply load it. I still have to read more about these parameters, how to set them up. And
I got a
what
question for you. How much of this notebook we're looking at, is this just the unmodified service pack notebook, or have you modified this in what you're showing?
no, this is all this guy's notebook. I haven't forked it yet.
Okay, I just want to make sure what you're showing us is what I would see when I get there. So when I look at it, yeah. Okay, thanks.
And so yeah, as this is a starter pack, it's just this thing, and maybe this, like that's what I was planning to do is start with this and maybe read as I read more about it, experiment and make it better. So now for the score, I think he got a very good, yeah, private score is 0.70 just with a starter pack of question answering, and public score is 694, which is actually very good. So yeah, that's what I was planning to do today, and just run this in my own Colab thing. So and learn step by step. Has anyone found another good notebook?
No, that was really good, man. That you pointed right to that. I think that's great.
Also, I was more when I try, I always first look up for basic approaches. So I was also curious if anyone has tried a workaround with Word2Vec or even TF-IDF models, but I did not find any notebook.
How would you imagine using Word2Vec for this particular problem?
Yeah, that's what I was curious. But I thought maybe because in Word2Vec, I figured if you, because there's many words here in this tweet which would not be in the pre-trained vocabulary of Word2Vec, but if you figure out a way to maybe manage out of vocabulary words, and then maybe just even assign a random vector to it, then it would be interesting to see how that works out.
Right. What I like, I've used Word2Vec, built models and stuff, but what I don't, I guess I connect the dots how you would actually use Word2Vec for the tweet sentiment extraction problem. I'm just having, I don't understand how you connect the two in your mind.
Yeah. I can't think right now, but that's what I was also curious. If there is a way, it would be very nice to see how the mindset would be.
So you have sort of a feeling there might be a connection?
Yeah.
Well, let's think about it. Okay. I mean, for me, what I think about, yeah, so it's like, obviously you can use Word2Vec as an embedding, right? And you can take the mean or whatever you do for each word and come up with a embedding for for the tweet text.
Yeah.
But then you might think, yeah, well, that's just, that's just one of many embedding methods. You could use the universal sentence encoder. You could use all sorts of stuff. So then let me just ask you, once you have an embedding of some sort, then how do you go to this information extraction problem from there? Do you have any thoughts on that? I don't. Yeah.
Like just treat the selected text as labels, so you get those embedding positions of what words are related based on particular sentiment and what fields are getting extracted, and then train a model on that. That's what I was wondering, if there is a way to do that. Just treat
Say that again. Yeah. Yes. Say that again. That was interesting. I
just select.
So use the word devec to
try the selected text as your labels, and based on that, you can find a position in which what words are lying in what position in your original text, and then train a model on that, like positioning thing.
What do you mean by positioning?
Like position tags, POS.
Oh, remind me what that is?
Part of speech.
Oh, a part of speech.
Yeah.
So you're talking about.
This definitely requires a lot of pre-processing and lots of feature engineering, but I thought someone might have done it.
No, yeah, but you're just so beyond me. I can't connect the dots. I say it sounds like an interesting idea, but I'm not sure I understand. Are you thinking about training a transformer model? That's what you mean, the POS tag?
No, so using Spacey, we can get POS tag for each token, right? And then you can get dependency tags, then you can get the other grammatical syntactic things, and then train a model to get extract selected text.
Well, I mean, that's what I'm doing with that's what I've been doing by training the model, right? Just you're going a little bit more under the hood. So let me ask you how does that relate to the word devec, or is that a different idea?
No, I was this was just an idea, a bunch of ideas throwing in, and I was trying to connect the dots between them and see if there is anything that anyone has done.
No, we're brainstorming right now. It's just all inside your brain.
Yeah.
I'm trying to pull out the brainstorm you had on your own, right?
Yeah.
So that I can engage in it and understand it, right? So I have bits and pieces of what you were thinking. I'm just curious to try to understand how you were thinking. So was there a relationship when you were thinking between the word devec stuff and the Spacey grammar stuff, or Spacey dependency tree?
No. But
okay.
when I was trying to do the first EDA thing, what I was trying to figure out is extract part of speech, entity tags, and dependency tags, and find out the relationship connecting those with that grammatical syntax with the selected text during the EDA phase.
Right. No, I get that. Yeah. So what you do is you create different features.
Yeah.
Like you'd be training on the features of the words rather than the words. And when you think about going from that Spacey parsed sentence and answer, what kind of model? I mean, how do you put that in a form and what type of model? Did you have any thoughts about that to train for prediction?
No, but that's where I was stuck actually, where I was looking for help on Kaggle.
Right.
Because in EDA, I figured maybe a pattern could be discovered that certain POS tags at certain positions are extracted more for the selected text. So
and that's a great that's a great approach, because you want to guess at whether there's going to be signal.
Yeah.
Right, and you doing that manually is not a bad thing, unless you have some big infrastructure you can just randomly run a ton of shit, right? So whatever it is.
Exactly.
And so you just think there was a promise in that?
I mean, definitely, but it needs a lot of feature engineering and lots of pre-processing. So it was taking a bit of time, but it's definitely worth trying it out. But that's why I was looking. If someone has done it, then maybe there is an easier way to move forward with that.
Yeah, of course. Can you imagine though? Let's talk about what you know about what we know about training BERT, right? So you have your your sequence and your padding for your sequence, but you have your tags, those special tags you put in there.
Yeah.
So somehow what I think you're thinking is you'd need to, if you were going to train from those syntactic or whatever features, you'd have to use tags, right? Isn't that what you'd have to do somehow?
Yeah, there's this. It's something like this, right? So this is each word in a different token, then the part of speech tag, and there's this IOB tag.
Yeah,
And
I mean, you could actually replace the text just with
yeah,
its features, right?
yes,
Or you could somehow replace the text with its features and the text itself. I don't know how you do that, so you'd have to know a lot about, right? I guess I don't know how BERT would work with that, but yeah,
yeah,
I mean, like that. That's the simplistic version, right, of how you could do it. Is just replace each word with its part of speech and just pretend that's the sentence and train on that.
exactly. And so it's just your POX. Spacey gives you dependency tags and many other grammatical syntax. So that's what I was trying to do, like create 3 extra features like POS, those grammatical thing, and then train the model.
Well, I have an
But
idea. I have an idea because I did this with Word2Vec. Make synthetic tokens. So what I mean by that, I don't know how that'll work with the token piece stuff, because it's breaking into pieces. But if you forget about the token piece and pretend it's doing whole tokens, what I've done with Word2Vec is you can just combine things with underscores. So instead of having whatever the text is, right? Let's say the tweet text has 5 words in it. It's a short one, okay? I love this stuff a lot or whatever. Take each word, go underscore,
okay,
whatever the noun, whatever it is, underscore, whatever the parent is in the dependency tree,
okay,
right? And now you have a synthetic token. I'm sort of making up this language. Don't want to confuse you, but so you have a synthetic token, and then that's your sequence. You've got 5 synthetic tokens. But those synthetic tokens now are not just the text of the word, but they sort of have more info in them. And so the question is, right, so you're loading up each word with more information, each token. Now the question is, how does BERT and the subword sort of process, does it, capture that?
right. Wow.
I haven't
Yeah.
read about that anywhere. I'm just making that up. So it'd be kind of an interesting experiment. It probably would just fail, but who knows?
Yeah, that's something worth trying. So for this, when I looked up the notebook, what they're doing is they're not using this POS as a feature. They're actually predicting part of speech and tag at the same time using BERT.
So you're saying they're like fine-tuning BERT through their own prediction process before they use it for the actual task?
So the notebook that I saw, what they do is they train the BERT solely on the sentence and word, BERT embeddings, and they predict part of speech and on one and the predict tag on the other at the same time.
Well, how does that get you to? I mean, you already have the. I'm confused.
No, that doesn't lead. I was just saying that doesn't connect to this project.
Oh, I understand. So what they're doing is they're trying to train their own parts of speech tagger.
Right.
Or entity tag or whatever. They're trying to take what Spacey does, use the Spacey output or whatever they're using as a training set, and then train a transformer to do the same thing.
Yes.
Ah. Right. So then what you're saying is in a way, you'd have the transformer that could predict that, but that doesn't really help with our task because that just gives you another way to do what I just, kind of what I just said. You're going to have a sentence, and you're going to assign its stuff to it. So it's parts of speech and so forth. Did you have any other thoughts on that, or do I understand that thread?
There's one more book, which is Tweet Sentiment Characteristic Words by TF-IDF. Someone has done it.
Is this for our extraction?
Yeah, our competition.
Oh, so what do they do with the TF-IDF? I mean, obviously you have to create a corpus, right? And you extract your TF-IDF.
Yeah, which is right here. Then they're creating a data frame. So we can see like 17,620 different vocab.
And they're trying to find the positive. How do they find those positive words? Because you have your sentence.
Yeah.
Is this from the training data? The tweet text?
Yeah, screen.
It is.
Yeah.
Oh, I see. I get it.
The negative, neutral. Oh, it's just exploration, not any modeling.
Yeah, they're looking at the top words. They must clean that up a little because when you do TF-IDF, you probably also would, get other stuff in there. But
interesting.
Looks like the site's back up. Somebody just posted a new one in a paper as well.
Yeah.
you're trying to find the TF-IDF when you were thinking about Parth?
Yeah. So there's one which is word-to-vec and fast text embeddings.
Oh, okay. And this is with the tweet task,
yeah.
The tweet extract?
On our competition, yeah.
Playing with word-to-vec. Interesting. Okay. So they're training.
So just simple pre-processing, I guess, because that's very important in word-to-vec. That's one of the things that takes a lot of time.
Yeah, you got to normalize the words because you're really trying to do is find concepts and words that are, and they probably have to stem it or whatever, lemmatize. There's a lematizer right there. Yep. They stem and lemmatize? What the fuck? Usually don't do both. Optionally shorten words. Oh, it's just there in case he wants to use it, probably.
Okay.
Yeah. Okay, he just uses one of them, or she.
Yeah, so pre-processed tweets, which actually doesn't help in this case because there are many selected text which are have those stop words included.
Yeah, I know. But what's he doing? Okay, so he's probably going to get it into the word-to-vec space here, right? Yeah, he's got a word-to-vec model from the clean data. Where did he train it? Oh, there's a fast text. Okay, so he's got a fast text from all the training data, a model, and then he gets similarity. And then what does he do with that similarity? That's what I'm interested in. He does shit, crap, and good.
Yeah, finding similar words. But yeah, so like good has similar words like today and tomorrow, which is
yeah, that's weird.
Yeah, good morning, good night is fine. Hope, that's good. and then training a word2vec on that.
Word2vec on the same thing. He's just playing with different models now. So now he's doing the Word2vec, and he does good today, Monday night. I don't know about that stuff. I don't think he's got a good Word2vec model, if you ask me.
But that's wow, that's interesting.
So that's all he did. See, he was just playing with models, right? He didn't apply it to, or she actually, I think, didn't apply it to our task. Did she?
No, I don't think he did it for prediction. No, just finding the similarity.
And I don't think it worked very well.
Yeah, because that's the thing. Our selected text has many noise in it, which that's why word2vec is a hassle.
Yeah. No, yeah, but he got past the hassle. The problem, I think, is they didn't train a good model. Like, I've used Word2vec, and you have to use just like 2 basic forms for it. And then there's, skipgram and the other one, and then there's a bunch of parameters, including your dimensions, right? And you have to do some hyperparameter tuning to get a good one out of it. And so I think this one just kind of failed.
That's interesting. We at work tried the vector intersection. Do you know about that? Like adding pre-initializing the words with Google News pre-trained model and then train it again.
What? That sounds pretty cool. What did you call that technique?
So Gensim has something called vector intersection. Word2vec intersect. So it's this one. So basically you can train your own model, but let's say the initialization that they do is random, that Xavier initialization. But instead what you can do is you can leverage the information that has already been pre-trained, like the Google News, and initialize the weights with those words.
Dude, it's just basically a form of fine tuning before there was fine tuning.
Yeah, exactly. It's just
right. Okay.
That way. So we tried this, and it was very interesting. It gave much good results.
So let me ask you. Tell me exactly again what you were trying to. What were you using the Google News, and then how were you doing this intersection fine tuning? What was your point of it? And what were you fine tuning with? Just state that again a little slower.
So at work we are doing this text similarity questionnaire thing. So just trying to find out future question, what is the most similar question in our question bank that is already there. So in finance company, there are many lingos that they call, which are not in the Google News pre-trained already. So we cannot directly leverage the pre-trained model because it's not going to.
Oh, I get it. So it was a classic just domain. It was a fine tuning for your domain.
Right. We tried 2 approaches. One is just using the pre-trained model and the new words that are out of vocabulary, like the lingo, finance lingo, just assign a random vector for such out of vocabulary, create a dictionary. But this one proved to give much good results.
So you added finance lingo via this intersection capability.
So all the words that are already in the Google News will be initialized, but the words that are not will not be initialized. They would be random, but then you train it, it finds the vector space for new words and similar words when you train it.
So you add non-initialized, then you just train using this intersection thing, or is that a different thing?
For this competition?
No, I'm just talking for your work use case. You guys were doing a domain adaptation of a Word2vec model.
Yeah.
So you're saying that you added non-initialized language into there, or randomly initialized, and then you trained it. When you said you trained it, does that mean you use this intersection approach?
Yeah.
Okay.
So yeah, exactly. And I just picked the representation from Kaggle itself. There's one good notebook for this. Yeah, Rachel. So just to go briefly, what they do is.
Oh, look at that, fine-tuning Word2vec. Can you post that in chat?
Yeah.
Because, when WordDevec came around, there was no such thing as fine-tuning. And basically, the only way I've used WordDevec is just building it from scratch. I know you can use the pre-built, but, in my work with all our IT stuff, because they're quick to build from scratch. They're pretty good.
Exactly. So that's why I was also curious how to manage out of vocabulary things on WordDevec, because it's not a bad model actually. And so I was curious, and I found this very helpful notebook. So they're training it on their Kaggle forum messages, all the messages in Kaggle forum. But definitely, as you expect, some of the words may not be in Google News pre-trained. So first, they train the model solely on this data, like from scratch, a word2vec. But if you check at the bottom, then they do a similarity between Kaggle and Google. So it will give you a key error because Kaggle is not in the pre-trained model, right? It's not a word in Google News pre-trained model. So what they do now is they build vocabulary of their own data. Then they add the vocabulary of Google News data to it. And then they do a word2vec intersect. So words that are common between them will be initialized, while the words that are not will be random. And then they train it again. So then
I get it. So you're going under the covers to the actual vocabulary, which is like the first part of when you're training it. It creates the vocabulary.
Yeah.
I get it. Okay, and then what?
And then then they get Kaggle and Google, and they get a similarity score.
Not a great one, but
yeah. Yeah, I'm not sure why they say it's pretty close to Google, but it's not actually. But I think they are only training on a sample. And the thing is, when we tried as well, this needs a huge memory, because when you do this model.vocab, we first did it and our RAM crashed 5 times because it's a lot of words.
Well, dude, the problem with doing this approach is, at least WordDevec's light, but it's like taking BERT and retraining. You're trying to retrain the original huge model, right?
Yes.
So you got the vocabulary from there. How much RAM did you have?
How much does Colab have? We do all on Colab. So.
Okay. Yeah. Okay. So that's why it's even possible, sort of, because look at that. That's what I was getting.
So, but there's a way on Colab that you can. I forgot how. You can request for more RAM.
Yeah. So okay. So back to our task, right? We were able to connect, at least with one idea, the spacey, right, dependency parsing stuff to our tasks through synthetic tokens, maybe, but perhaps maybe there's other ways to connect them, but also from this WordDevec idea, I'm thinking, we've now sort of gone into different ideas of how you train it or fine-tune it or build it from scratch. But other than embeddings, I don't have any ideas of how you connect it to our task. I'm just summarizing where we are. I'm not making a value statement or anything. I think that's interesting.
Right.
I'm framing it for you.
Yes.
Where we are.
So I was definitely, that's something I would do on the side to figure out maybe if there are any good resources, not even on Kaggle, but if anyone has done any implementation, I guess it would be give me a clear understanding of a right workflow. And at the same time, definitely I would do transformers question answering as well.
So I have a question, I guess it's a more generic question. So I think I've seen this. This is really good notebook, because I've seen. I think we discussed fine-tuning word2vec before, but there was no examples. So this is really useful. But my question is, should one do it? So at this point, so and this is something I also trying to figure out. So let's say we have BERT now, right? That does tokenization. So BERT doesn't have unknown words at all. because they tokenize up to characters if they don't know any better. And then alternative is, let's say with Word2Vec, you basically learn those words, new words. Can one say that results would be better with specific token for the word? Or if you keep it as bird tokens, result would be comparable?
You're talking about which embedding would be better?
Yeah. So
Carry
let's
more
say like example I actually have at work is like a chemical formula or chemical name that's not in the normal vocabulary. So when I was using Word2Vec, or I was actually like just using them as like a unique, just unique words.
Yeah.
And actually, I was trying not to use embedding at all for them till I saw that trick that you can actually assign random embeddings to them, and that works also well because that's.
I'm sorry, what I meant by embedding is just, really a vector space, that's all.
Yeah.
You've got your Word2Vec, yeah. But I'm with you, whole tokens
Yeah,
in Word2Vec
and then
versus...
alternatively, like with Bird, if Bird doesn't know it, it will like split it into parts and create vector for it. Or
Well, fast text does that too.
yeah. So my question is, is it better to create is it better still to create new tokens for new words? Would that give better performance?
So you're sort of musing over the difference between whole models or algorithms that use whole tokens versus subword tokens, right?
Yeah. So
and
so let's say
whether or not the whole words might have an advantage, even though it's an older method, because if you actually know all the whole words, right? Like if you know your whole vocabulary, maybe it is better.
Yeah.
Is that what you're thinking?
Yeah, and even within BERT, let's say I know in my specialized vocabulary, should I add those words? Like should I?
Well, but you add them through your sequences while you're training in BERT, right? Your sentences. How else do you add?
So normally when I do tokenization in BERT, right, it needs to. And actually, I've never done this from scratch myself. I always like use existing tokenization, but I guess like you need to add your new words somewhere so like the tokenization knows about them.
No, you don't.
No.
I mean, look, this is a half-ass understanding, but with those subword tokenization models, they take you don't give them, you give them your training text or whatever, however much text you have, right? And it takes that world of text, whether or not they're, in your case, a chemical formula? What was that?
Yeah.
A chemical formula? Or what would you call it? Okay.
Yeah, like a name of chemical compound. Yeah, it's not
Let's
a
say chemical compound names.
Yeah.
I mean, maybe they show up in your literature, or maybe you make synthetic sequences. But my understanding is, you take your corpus of content, right?
Mm-hmm.
And in your case, you're just thinking of it as having a whole lexicon, right, of formulas. I mean, of chemical names. And you feed those as if they're sentences into the tokenizer, and the tokenizer will break them into parts, right, and count them. And it has a limit of, like, this vocabulary can only be 10,000. I don't know what the default is, right?
Mm-hmm.
Pieces of words. Mm-hmm. And it'll only keep the top, most informative 10,000 word pieces. That's my understanding of how that tokenizer works. And then you have this vocabulary that's pretty small, and it's consisted of pieces of which would be great for the chemical stuff, right? Because chemical names probably have they're probably systematic in a way, right? You probably see the same sub pieces in a lot of different chemical names, right?
Yeah, yeah.
So am I completely missing your?
No.
Am I misunderstanding that? I mean.
Yeah, but still, like, so there is no way to add tokens unless I'm using it all the time. Like, so it has to be really popular for BERT to decide that it needs to be added into vocabulary.
Yeah, I know. Actually, I don't know. I really don't know. But that's a good question because, like this WordEffect stuff, when you train it, you have you can go your model dot vocabulary, right?
Mm-hmm.
And we just showed how you could monkey with that vocabulary under the hood, like just take the vocabulary from two of different models, combine them, and build another model out of it. So can you do that with BERT, or can you monkey with the vocabulary in BERT? I don't know. Does anyone here have any sense of that? Parth, do you have any idea? But that's what you're thinking about, you're right?
So I guess this is the big advantage of the, whole word well,
yeah, the context free. Yeah.
Yes, so you can actually, decide on your own tokens or sub pieces.
Although when I train a Word2Vec model, I mean, I just, I trained it on our editorial content. I didn't try to control the vocabulary. There's parameters, but, you pre-process it and clean it up, so you're going to get ideally the same, you're basically just normalizing the words so that they show up in the same place in the Word2Vec model, right? So, but I don't feed it a lexicon, right, of names.
But then you have after you train the model.
Yeah, if you train the model, you have vocabulary. Same with BERT. There's a vocabulary in there. But BERT, actually, the thing about it, it's sort of like a distributional trick, right? So with the subword tokenization, it actually, with 10,000 subwords, it covers it covers everything.
Yeah. Yeah, because
all possibilities.
It goes all the way to characters. So.
That's right. If you can't find this piece, it'll keep breaking it down until it can find a piece that makes sense, right? And so it covers the whole vocabulary, so there's never out of vocabulary issues. I know, God, I need to start really using the deep learning. I'm trying to slowly do the new Fast AI course, just teeny bit at a time because I don't have time for it. But my knowledge of deep learning is pretty weak, so I need to do more with this stuff, and I need to start going down that path. But I did. So then at work at the same time, it's like I'm having to start with a rules-based approach for something at work right now, like pure regex, to get something out quickly as a baseline. So, which is fun and interesting actually, but yeah. I would say your question would be good in a little bit of a broader audience, right? Where some people have a little more, like our Saturday calls we used to have or something.
Yeah, maybe I'll do like a little experiment just to because I had this question and then I saw before and then I saw the Word2Vec this Word2Vec notebook and I started thinking about this again. But yeah,
have
maybe
you used have you used Word2Vec directly?
Yes. And
okay.
Results were like not that great for my task. That's why I switched to BERT.
Yeah, I think I always thought that managing out of words, vocabulary words, is only in Word2Vec. And fast text, they all we use a tokenizer, so if it's not in their vocabulary, it just splits into subwords. So I never realized in other embeddings we have to do it.
That's funny. You're coming from the other way. But the real control you have over is what you feed into it and in what order. I call them the sequences, but the sentences or whatever, right?
Yeah.
You can affect your vocabulary also just by, like making synthetic words.
Yeah.
Like we talked about. I mean, I haven't done that with BERT. I've done it with Word2Vec as well, but I don't know. Here's the thing. So I'm going to start researching this right now real quick, Yuri. So here's people that are like, how can you use my own vocabulary dictionary in BERT, right?
Cool. It looks like Kaggle is back. I was able to follow the links.
Yeah. And it looks like somebody posted a new notebook of an hour or so ago with a paper as well. I don't know how it applies. You guys seem to be more familiar with the topic than me.
Oh, you're in the competition under the notebooks? Is that what you're?
Yes. And
Oh,
it looks like somebody posted one with a paper. I guess he implemented the papers.
Excuse me. Still slow.
Where is that notebook? Is it in the competitions page?
It is the one I was just talking about.
Yeah.
Yeah, it's on the competitions page. But I don't know if it's.
So what's it called? I'm at the notebooks right now.
It just BERT Twitter sentiment extraction. It's just somebody did it recently. I don't know what that. He has a paper in it as well. The full paper is
I
actually,
see it.
yeah.
You see it right, Barth?
Oh yeah, I think it's by a guy called Simon. Yeah.
Yeah. And then he has a paper attached to it as well. But, Yeah, I have a question, guys. What is a good resource to get a good background on NLP? I mean, you guys go back and forth, and I just listen in, but um,
Wow, that's a big question.
I figured as much.
Well, I mean, obviously you have to attack it from different angles. One angle
Mhm.
is classes, right? And there's a couple
Yep.
pretty well-known ones
Okay.
that are like videos. And, there's the Stanford one. Has anyone here have ideas in terms of video courses other than the Stanford? I don't remember what the name of it is, Stanford NLP course, but
Try to find
Yeah,
it.
that's a good one.
Okay.
I like 2 weeks ago, I just started it, so I finished the first lecture. It's very good. It starts from the basics.
yeah,
Okay.
that's CS224N. Is that right? Natural language processing with deep learning. But I think they start off. Is that the one part?
Yeah, so the winter 2019, I think that's the latest, which is on YouTube.
Yeah.
You said CS22.
Yeah,
224.
For
let's. I think I have it here. I'll post. I'll post it.
Okay, great.
And then look at see if you can find your way to the videos here. Let me see.
Okay.
Come on, Darren, you can do it. There you go. I think that's it.
I think there's a study group too in TWIML, but I think they're very far ahead, so I wasn't able to join now. But there's a study group as well.
So there's also the Fast AI NLP course, but it's a little old at this point. I'm not old, but they've updated the Fast AI libraries. But that's how one thing I started all, not NLP starting from, but when I started all this sort of community participation stuff last winter, 2020 or whatever, was the I don't know if you were there, Parth. It was the Fast NLP. So there's also a series of there's a class, a video class, just like the Stanford one, but it's with the Fast AI NLP. Did anyone here do that? It was Joseph was leading it.
No.
Yeah, I've done that.
Yeah, so that's another way. So either you could do either one of those classes, and you could do them. There's study groups that do it, and you could do it with a study group like we're doing now, or just do it on your own.
If you are if you have a specific like you specifically want to look at this Kaggle notebook, I found that so Spacey has a really interesting tutorial. I found that to be very useful, and you follow them, and you after that you can do a lot with Spacey.
So that's the video tutorials they came out with.
Yeah, I'm gonna post it.
Dude, it's a freaking crazy world in NLP. I mean, there's so much disparate stuff. I mean, you can use all I've been one of the main things I did last year was LSI, latent semantic indexing. That's old school and all that, but it was wonderful for what I needed, which was sort of conceptual search. But there's just so many different techniques, man.
I see. Understood.
That are completely different, although they have certain underlying themes, like words that occur together tend to share meaning, that sort of thing. And there's fundamentals like tokenization and which has gone crazy in the last couple of years. Tokenization used to just be tokenization. Now there's subword tokenization, and there's what's the other one? I don't remember. And there's really the fundamental thing is how do you take words and put them into math, right, into a matrix. That's the fundamental thing, and you learn that through TF-IDF, scikit-learn, and so you get things into a vector space, right, and then you can do things with it. But I don't I wouldn't necessarily, it depends on you, but I wouldn't necessarily worry about the math too much. I'd worry more about patterns of practice.
I understand. Okay.
Yeah. Like you could totally, like, I don't know shit about math. So, I mean, I had calculus in college. I'm not a complete idiot, but you could
More
be a
applied.
complete idiot and do all this.
You're like more applied, just making use of the tools that are out there, and
Yeah, I mean, it depends on your learning style, but really, I would say, that patterns, identifying patterns or practices in notebooks, and maybe ones that are in the context of your work or something you can imagine in your life. Of course, everyone always says that. It's like code first learning or project first learning or patterns of practice first learning. So I would approach it from, and then drill down deep where you're trying to do something and it's not working, and you're trying to figure it out.
Okay.
So I hope we haven't been completely useless, but
No, that's awesome. I mean, you learn something every day. So.
Remind me again where you're at with your stuff. I know you're transitioning. I can't remember what your base is.
Yeah, my base is
core.
more, on the database side of things.
Oh, that's right, because we talked about
side.
data. Didn't we
Right.
talk about data
did.
ops stuff a little bit?
Right. So, that's where I've spent most of my time. So this is rather new.
Yeah.
I'm enjoying it. It's just like you said, it's just so much. And then this is just this one area, there's the vision side with its own set of everything. It's
Are you doing other groups?
I am in the machine learning, with hands-on machine learning group.
Okay. Which is the
Joseph
book?
is
Is that a
doing.
book group?
It's a book group, yeah.
Yeah, so that's great. That's great. The other thing, of course, is if you do want, which I'm trying to do now, is the fast AI deep learning for coders. That's a classic way now to get into, not classic, but to understand the fundamentals of deep learning. Do you know that they just published a brand new one?
No, yeah. Book.
You want me to post it, or do you already have that?
No, that's good. You can just in case.
Yeah. Excuse me.
I've spent a little time doing it, but I think I wasn't concentrating in any area. I was just all over the place. And I think I did go down the bunny trail of, my math, as you were mentioning, was a long, long, long time ago. So I probably spent more time looking into that than I probably should have, as opposed to just, taking more of the applied approach.
Yeah.
I mean, it doesn't hurt, but like you said, I probably would be much further ahead.
Well, people go down the rabbit hole and the intimidation hole of
Yes.
math and of theory. And the whole fast AI thing is you don't need to do that. You learn from code first, project first, and then you learn what you need to learn, driven by problems you encounter, right?
Gotcha. Okay.
And that will get you a long way in the world of being able to do stuff that matters. That's their philosophy. But here it's called Practical Deep Learning for Coders. And let me just go in there to chat. There you go.
Thanks, sir.
And if there's a book, you don't have to have the book. There's notebooks, each notebook for chapter. There's a video lecture too, so you have the trifecta. YouTube, Jupyter, and a book. And of course, Jeremy's awesome, so he's always fun to watch.
Okay.
But that's purely for deep learning, the basics of deep learning.
Right.
Understood. And it's not theoretical at all. They have the Fast AI library. That's how you learn from that library.
Okay.
Which you then drill down into PyTorch as needed, and I think you learn PyTorch. So, all right, guys. I'm about ready to get back to work. Is anything anyone else? I'm going to drop off in a second.
Oh, you had a notebook. You're going to share it, or?
Oh yeah, well, let's see. Maybe I can get to it now.
Yeah.
We can do it real quick, but I don't think there's anything very new for this call. But let me. I think I've showed it before, but I guess it's updated now. Let me see here. Okay. I don't know how to share it with you guys. I mean, I'm going to open it now, and I can do my. I think you just either make it public or you don't. I could make it public, I guess. I don't mind doing that.
You need to make it public to share it.
To show my sub 6 point whatever. I might as well do it.
But,
All right, here
you
we
know
go.
what? Wait.
My embarrassing score. Okay.
No, but at least we can follow it, you know, and then if I have questions, I can ask you as opposed to just somebody out there.
Oh, totally. No, I'm doing it. It doesn't matter. I don't give a shit. Dude. Okay, public.
Awesome.
I'm going to copy the link and I'm going to save as public. And I'm going to give you guys the link. Excuse me. And there's the link. And I'll do. Did you guys want me to quickly run through it via screen share, or is it good enough just that you have it? You guys can look at it later. Either one. Let me know if someone wants me to go through it or not.
Yeah, maybe that would help.
Okay. I will do that. Hold on a second. Just take me a second here. Let my wife know I'm alive here. Okay, so let me share my. Sorry, guys, it's clearing my throat so much. I don't know what's going on, but here we go. Let's share the screen. Okay. You guys see my screen?
Yes.
Yes.
This is a stupid little Python thing, but in newer versions of Python, you can use this thing called breakpoint for debugging. But the version they have on Google, at least, you have to install it. So I install IPDB instead. I have to use that. Data prep, nothing exciting here. You got test set, just load it. Training set. There's one null value. I learned that from some people's EDA or whatever, and I think I dropped that. Here's the Jacquard. So that's our metric, just cut and paste, you know, from the competition. And I'm just adding some numbers here. So I have token counts and things. You could see them right here. And I did some, I don't know, this is just from my EDA earlier. I left those extra fields in there. I think I use them later. But is this the right frickin' one? Sorry, guys. I might have just shared the wrong one. That fucking sucks. Yeah, this is the one I meant to share. Sorry. Okay, I'm just sharing everything while I'm at it. Okay, so I'll share it, though, and I'll share the... Okay, now I need to put it in the chat. I think things move around when you're actually sharing, so where is the chat? That is so annoying. Oh well. Remind me when I stop sharing, I'll chat it. That is really annoying. Okay, guys, so here we go. Again, it's just... Okay, this is much more slimmed down. This makes sense. This is just for submission. I slimmed it down. There's Spacey. Just showing my version of Spacey. Prepping the train and test set. I do get the tokens there. token counts. I also get the neutrals, because you have to deal with the neutrals just return themselves, and you've got that boosts everything, because we know that the neutrals, it just returns the entire text. And then here, I should show you what matters here. Hold on. I haven't looked at this in a while. Okay, here's my helper functions, which I stole a lot from another notebook. And then I'm just taking notes of my my trainings of what happened. You guys can see those if you want, real quick. So I'll show you how I train this from scratch model Spacey, but these are my results. So, so obviously I got a lot better. I obviously overfit locally, probably, so I probably need to do some sort of cross-validation when I train or something, because I did not get that score. What I ended up with was, I showed you guys what I ended up with, right, which was, this is what I ended up with right there. Okay, so here I'm training. So I guess all the info on how it's trained is actually in the helper model. So I'll go back to those. But here it's being trained. It's training so it trains two different models, like always with this stuff: the positive and the negative model. And then there's my results from. So let me show. I'm doing a terrible job of this, guys. Hold on. So let me see if we can make some sense in the helpers here. So here's the train. Let me see something. So here's sort of like the master, which helps you run the train function. So you run for each positive and negative, you create two different models. And you define your directory, and then you run your training. You get your training data. That's another function up here. And then you run your training. And that is this function up here, custom function here. This is what, I guess, what matters, right? So here you set up your pipeline, okay? You've probably seen that before in Spacey. And all you're doing is you're eliminating everything. Spacey pipelines come with a bunch of different processing in them, different stages, and you get rid of everything but the NER. You make sure there's an NER stage in there. And then you let the Spacey model know there's a new label in town. I think add label to pipeline for novel entity. I think that's what you're doing, yeah. See, NER, that's your model. And that's your so you instantiate your model with your pipeline, and that's your model. And you're adding the tag. And then here's where I add or don't add the pseudo. Here's a place where you could add that pseudo rehearsal data. So you take your training data, and if there is revision data, you add to it. That's the pseudo rehearsal. But I didn't do that in these tests here. Or you're disabling all the other pipes here, and then you train, I guess. Here's your batches. So, yeah, I mean, I don't really know that. I mean, I don't know what to say about this. You do mini batching, and you take your batches. So up above is just preparing your model and your pipeline, and then down here you're feeding a batch at a time into update. So you're just updating your model. I mean, that's what you do. I mean, you load a model. I load a blank model. So up here you can load a blank model, or if a model's given, your model, they call it NLP, your model becomes the model given. And that's when you're trying to use an existing model that Spacey offers. Not an architecture, but an actual trained model. You're always using the Spacey architecture. And then in this case is where you do from scratch. So there's no model given, so you load a blank. Your NLP model becomes your blank spacey model. And then down here, you're just training it with batches. So you've seen all that part, right?
Yeah. I was just curious how what the pseudo rehearsal was incorporated. So I saw that.
Okay.
Uh,
Oh, I could show you my fuller notebook, and maybe it has my pseudo rehearsal in there. Sorry, I just droned on about.
no worries.
So let me. I think it's right here. So let me see if there's anything useful there. There it is. So training variations from scratch, small, just starting a model instead of from scratch, from small, large, and then to Dilbert, which you can't do at all actually. Here's my pseudo rehearsal stuff. So here's the key, although it's a small model here, but you see what I'm doing here? I'm actually loading a model before I train. Like I'm loading a pre-built model, right?
Yeah.
And then here's load revision text. So okay, it's the golden data. That's the main thing here. I'm taking this downloaded data set I got, and I have to put it into the spacey training format. So how do I do that? I don't really remember, but.
So in the gold parse, we pass the tags that this model already knows, right?
Yeah.
Okay. Oh.
So here's the revision data. Remember where I was showing when I was training, you have revision data?
Yeah.
And then the training data, right? So I'm putting, that's right. I took this, from an example and adapted it a little bit. But yes, so you're putting so your revision data, you're basically preparing this pseudo-rehearsal revision data to use to add to your training data. And you do it, this is the form you do it in. That's a spacey doc object you're familiar with. And then you do this gold parse thing. And you see what you're doing here? You're getting the tags, right? From the doc model and spacey. You totally, I remember you used all that stuff with the country stuff. You're just getting the tags, the heads, whatever those are, the dependencies. So you're getting that whole dependency parsing structure stuff, and you're just putting them into this gold parse thing.
Got it. Okay.
And then in the training helper, you'll see here, I think here you've got your revision data. I just added that, so it knows if you're trying to use your. It just does the same thing, for positive and negative using training, the training function, but it knows that you have revision data, so it's doing the same thing it would do with your training data, right? Okay. Except for it's just adding it in right here, so you have more data you're training with. So you're training the existing stuff also.
Right.
Pretty straightforward, more or less, except for it didn't work well.
Okay, got it. Thank you.
Yeah, okay. All right, guys. I think I got to go, so I'm going to have to leave.
Thank you.